Hello and welcome to Tutoring Potential. Today we are covering the Geometry End of Course Exam review and explanations. This will start with problem number 20. This is part C. Okay, Aisha wrote a proof given the statements and the figure shown below. Okay, these proof questions are just take a little time to look at and see what they're asking us. Given, let me use my figure. Given CD is equal to, is congruent to AE, and AD is the perpendicular bisector of CE. So these are perpendicular, these are equal, and these are equal. Prove that triangle CBD is congruent to triangle EBA. Okay. Which correctly replaces the question mark in Aisha's proof? And that's the final reason. What I have is, really I can do this from here to here. Given that CB is equal to EB, CB is equal to EB, and given that CD is equal to EA, given this, given the circles, and given the rectangles, which means that this is congruent to this is congruent to this, why can I say that these two triangles are congruent? Well, I do need that they are right triangles, so I guess I do need this. Whenever I see that it's right triangle and triangle congruence, you want to consider a hypotenuse leg, HL theorem, and that's what we're going to use here because it's giving us the hypotenuses are equal, and that this leg is equal to that leg. So that's the hypotenuse leg theorem. Oh boy. Given the figure below, which of the following statements is sufficient to prove that ABC is similar to DEC? That this triangle is similar to this triangle? Well, I've extended this line because no one ABC and CAB, ABC and CAB are congruent. This is not going to do it because it relates one angle to another angle. It's just saying that this is isosceles. It doesn't say anything about this triangle. The vertical angles are going to give us just these two. Just this one angle is congruent to this one angle, and I need all three. I really need two, because if two are, then the third will be by definition. But if AB is parallel to ED, then angle A is going to equal angle D by alternate interior angles, and angle E is going to equal ABC by alternate interior angles. So that's going to give me similarity. Yes, the vertical angles are equal, but because these two are corresponding and equal, this to this and this to this, through alternate interior angles, the third will be, because the sum of the three has to equal 180. One is trying to line the perimeter of a triangular campfire area shown below. Okay. Which order of line segments corresponds to the number of stones necessary to line each side from greatest to least? Basically, which side is greatest? Greatest to least sides. And that's going to go opposite. The greatest side is opposite the greatest. The longest side is opposite the greatest angle. So the longest side will be AC. That knocks out these two. And then across from the 60 is AB. So it'll go AC, AB, and then the third one BC. Oh, that's not a good sound. Line segment BD is an altitude of ABC. What is the length of line segment BD? Okay. The altitude BD is the mean proportional between AD and DC, which are the leg's projection on the hypotenuse. You don't have to worry about the terminology, but the small side over BD is equal to BD over the longer segment, of the hypotenuse. So that'll give me 6 times 18 is equal to BD squared. BD squared is 108. BD is the square root of 108, which is 6 root 3. I'm not going to go over rationalizing or simplifying radicals. What you could do is put the square root of 108 in the calculator and 6 root 3 in the calculator. 6 root 3 root 108. And I don't know if you can see that or not, but they're both 10.3923. Gia has been hired to paint a triangular mural. She begins to make the plans, but only knows the measurements shown below. What is to the 10th of a foot, what is the longest side of the mural? This one. Alright, well this is a 3, 5, this is a right triangle. They're both right triangles. 3, hypotenuse is 5. 5 squared minus 3 squared, 25 minus 9 is 16. Square root of that is 4. So this part's 4. This part is a 30, 60, 90 right triangle. So across from the 30 is 3. Across from the 60 will be 3 root 3. So this 4 plus 3 root 3, which is to the nearest 10th, 9.2 feet. Yvonne is creating a stained glass window design. She wants to cut a triangular piece of glass to cover the portion of the circle as shown below. The measure of the minor arc AB. Right, the minor arc AB is here. The 74 degrees. CB is tangent. So I've redrawn this to E because CB is the same as EB. So this is tangent. I've drawn the other tangent from A. Not well, but it's there. What is the measure of FEB? What is the measure FEB, which is half of AEB? FEB would be here. Okay. Well, what's going to happen is 2 times FEB is AEB. So that's what I'm working with. This way I don't have to divide by 2. 2 times FEB is equal to 1/2 the major arc minus the minor arc. So the major arc is just 360 minus 274. 360 minus the 74, which is 286, which is this to A to B, but the long way. So basically 286 minus 74 is 212, and then I'm going to divide that. Either way, I do half of 212 and divide that by 2, right? And I get 53 degrees. 53 degrees. Choice C. I will notice that the test doesn't cover tangents as much. I think that's the only question. So normally you'd have, you might have chords inside the circle. It's not as concerned with chords and tangents as last year, if this is anything to go on. I can't say for sure. It also doesn't have in-center, circumcenter, and the third one, which is slipping my mind right now. Anyway, there's some terminology that's just not on there. I'm not going to worry what's not on here. I have to assume that this is closer to the exam they're going to give you. A yard in the shape of a square has an area of 400 square feet. Several sprinklers water a circle of lawn inscribed in the square. One covers the shaded area in the circle as shown in the diagram. Well, mine's not shaded, but I have to think it's here. The arc of the shaded portion is 136, so it is here. So the nearest whole number, what is the area of the shaded portion of the circle? Okay. The area of the square is 400 square feet. The formula for the area of a square is s squared, so I take the square root of 420. So this is 20, which means that the diameter of the circle is 20, which means that the radius is 10. And what I do is the area of the sector equals the measure of the angle at the center. That's not going to come out very well. Over 360 times the area of the circle, which is pi r squared. So that's 136 over 360 times pi times 10 squared. So that's 100 pi times, which I just used 314, 3.14 times 100. 314 times that fraction. So I guess I'll do it. 314 times 136 out of 360. 118.62, which is 119 square feet. It can't be 475 because the square is bigger and the square is 400. And 136, right? It's less than half. It's less than half of the square, so it's got to be less than 200. So it can't be C or D. Okay, it's B. The equation of the circle Q is given by x plus 1 all squared plus y minus 3 all squared equals 4. Which of the following is the graph? Well, x minus h all squared plus y minus k all squared equals r squared. So the center is at, I changed the signs, -1, 3, and the radius is the square root of that number, which is 2. So the center is at -1, 3, the radius is 2. Answer choice D. And one more of these. Circle has the equation x minus 4 all squared plus y plus 9 all squared equals 5. What is the center of the circle? Again, I'm really changing the signs. X minus h, so it'll be positive 4. X plus 9, so it'll be negative 9. 4, negative 9. Choice A. I will note that normally, traditionally, these are saved for Algebra 2 when you do conic sections. Circles, parabolas, hyperbolas, right? So it's a little odd that they squeeze them into geometry. Which is not a triangular prism? It's going to be this one, because if I go to try and fold this up, there'll be an open side here. As long as the triangle's on either side, it'll be okay if it's moved up or down, but I can't have two on one side. So that's why the C is not a triangular prism. The following is the net of a polyhedron. How many edges does it have? Well, here's like, yes, this is an edge, but what happens is if I fold this, I get a cube, and it's saying how many edges is in a cube. So if I just draw it, the sort of how we, attempt to draw 3D and count the sides, I draw 4, 8, 9, 10, 11, 12 edges in a cube. Okay, if you count all these, you're going to double count a bunch. Okay. Here basically this is a cylinder with two hemispheres, and I want the surface area. Well, the surface area here is going to be pi r squared h. Okay, for the 12. That's where I know this is just trying to fit this into the last minute here. Pi, if this is 1 inch, the radius is 1/2. Pi times half an inch squared times the height, 12, is going to be the tube part. And then if I put these two together, I get a sphere with the radius of half an inch. And that's area of the sphere is 4 pi r squared. So it's 4 pi, the radius is still 0.5, squared, and then plus the cylinder part, right? And I leave the ends off because the ends aren't here. The ends are the sphere. So 4 pi 1/2 squared plus pi 1/2 squared times 12. All right, I'm going to go ahead and cut it here. Thanks for watching. Please comment in the section below if you have any questions. If you have any corrections, please let me know. Again, thanks for watching.